Hi everyone, welcome back to Cody's Lab. So as you can see, we're using the vacuum chamber once again, and I actually have a little feather right there, as you can see, suspended in front of a 12-volt electric fan. See, I got the batteries, a pressure gauge, and everything in there. To turn it on, I have a little tilt switch that says magnetically controlled. You can see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. So, I want to take this down to Martian conditions. You might have noticed the Martian reference over there. First thing I'm going to do is add a little bit of dry ice to the chamber, just so that the atmosphere gets replaced with CO2. Many of you guys were complaining about that last time. So now I should have a CO2 atmosphere, or at least it'll create one. And now we're going to suck out all of the air, or at least most of it, down to the point where about between 4 to 6 millimeters of mercury, which is of course the pressure on the surface of Mars. So let's plug in the vacuum pump. There we go. Give this a little while to suck down. If you can see the gauge over there, you can see that the air pressure is just about to the point where it would be considered the surface of Mars. So since we're at Martian air pressure, let's unplug the vacuum pump and let's turn on this fan. Place your bets as to what's going to happen to this feather. Now the fan's only going to produce maybe 10 miles per hour worth of wind. On the surface of Mars, the fastest recorded wind speed is about 70 miles an hour. But let's say the superstorm in the Martian had wind speeds of 200 miles an hour, 20 times what we have here. To compensate for that, I imagine the feather is about 20 times easier to push over than a spaceship. So let's see what happens. Okay, fan's on. And the feather's not moving. In fact, let's zoom in on that. Not even flinching. Let's turn the fan off. Okay, and let's turn it back on. Okay, so there's a little bit of a sway that's caused by the wind that's produced by this fan, but it's not nearly what we had before. It's hardly even noticeable. So there you go. Now, extrapolating from that, you can imagine that even a 200 mile an hour wind on Mars isn't going to do much. So to finish up this experiment, I'm going to turn this fan back on, just like this. And now I'm going to let the air back in, and let's see what happens as we come back to Earth. Yeah, almost immediately you can see the feather start shaking around more and more violently. Okay, so the air stopped coming into the chamber, so now everything's due to the fan. What I think is interesting is the fan actually sounds different. It doesn't vibrate quite as much. I guess it is designed to run in an atmosphere. So there you go. The air density has a big impact on what wind velocity actually does. Hope you all enjoyed. I'll see you next time.
Okay, today I'm going to be seeing if flies can fly in a vacuum chamber. So today what I want to test is if the flies can actually fly with the low pressure in the vacuum chamber. So I've already shown in my previous video that being in the vacuum chamber itself, the low pressure doesn't really affect the fly at all. And it definitely wasn't torturing the fly as some people accused me of. But one thing that bothered me when I did the spider and the fly in the vacuum chamber in my previous video is that the fly never tried to fly. it never tried or even attempted to fly because it was a really big, fat, old fly, and that's how I caught it so easy. And so it never attempted to fly, and it bugged me because I wanted to see it try to fly and not be able to. Okay, they're all awake now. Let's see if they can fly. So I have a little magnet in here where I can go get them and try to make them fly. Okay, can flies fly in a vacuum chamber? 3, 2, 1. Okay, we're at 0.8 atmospheres. They're still flying. 0.6 atmospheres. Still flying. Half an atmosphere. They're having a harder time flying. They keep landing, falling onto the ground. Okay, we're at 0.4 atmospheres. They keep falling to the ground. Yep, they can't fly. There's one more up here. So we're at 0.2 atmospheres. Let me pause it right there. 0.2 atmospheres. See how they just fall to the ground? There's one right here. So this isn't even at full vacuum. Okay, let me get it down a little more. They can't fly. Okay, we're only at 0.1 atmospheres, not full vacuum, but they can't get. They definitely can't fly. That's so weird. The flies have now become walks. That's so weird. Okay, now I'm gonna increase the pressure and watch them start to be able to fly. Turn on the air. 3, 2, 1. They can fly. So what's cool about this, you'll notice that the ability to fly is completely dependent on the density or the pressure of the air. So these flies can fly just fine at atmospheric pressure, but once we reduce that atmospheric pressure, they couldn't fly anymore. Okay, today I'm going to be putting a drone in my vacuum chamber and showing you the difference between propeller-based flight and rocket-based flight. And then after the drone, I'm going to be putting a balloon in the vacuum chamber that will act as my rocket to show how rocket flight is different than propeller-based flight. So this is my drone I bought on Amazon. So how a drone flies, obviously, is that those propellers spin, it creates lower pressure on top, higher on the bottom, and it pushes the drone up. But a key feature of that is that you actually need air to make that happen. So let's see what would happen if we take all the air out of the chamber. Do you think the drone would still be able to fly? Let's check. Okay, and what I'm gonna do is I'm gonna turn on the vacuum pump, and then I'm going to fly it as I pump out the air, and let's see if it goes down as the air is getting pumped out. Okay, drone in a vacuum chamber. 3, 2, 1. Okay, I'm just gonna let it hover there. About negative 0.5 atmospheres. I'm having to throttle up more and more and more. Negative 0.8 atmospheres. Look, it's full throttle, it can't even get off the ground now. I can't do anything. Okay, so you can see the propeller spin. It's essentially just vibrating on the ground right now. And what's cool is look how long those blades spin after I turn it off. Turn it off, it just barely stopped because there's no air resistance. Okay, now I'm going to slowly increase the pressure and see if we can get it to fly. So I'm gonna have it on full throttle. Full throttle, I'm gonna let in some air. Oh, there it goes. See, now it has no problem. Oh, it's at the top now. See, now I got a down throttle.
Today I will try this tiny quad drone forced to fly in a vacuum. Let's check if it works. It seems to work, but we need a pilot. Okay, let's start. Putting this tiny drone in the vacuum chamber and beginning to pump out the air. As you can see, as long as the air is not completely drained, it flies. But when there is no air in the chamber, it can't even take off. Since there is nothing to catch on for the blades, just like with real helicopters, which can't fly so high because of the same reason.
Cognitive dissonance. This is a real effect where people have a certain worldview, they're confronted with evidence which conflicts with the worldview, so they have dissonance, conflict in their minds. What's generally done, instead of changing your worldview, which you may have held your entire life, you dismiss the evidence, and along with that you dismiss the authorities that may have provided the evidence. Instead of changing your worldview, which you may have held your entire life, you dismiss the evidence. Instead of changing your worldview, you dismiss the evidence. Instead of changing your worldview, you dismiss the evidence.